Okay, I'm glad you're here. Every
Yeah.
once in a while, I wonder if something's going to happen, and at the last minute, and I'm like, oh, well, okay, so how am I going to wing this? And I was just looking
Oh,
for
well,
some fun API I could live code, like getting data from an API and putting it to a table and stuff.
just gotta run through the four notebooks. Call it a class. We'll talk about next. I will talk next week offline though, Karen. But we'll talk about that later. But we're recording right now, so yeah, we'll get started. Hello, welcome. This is week 9 of the IBM Data Science Professionals Certification and 10-week boot camp. My name is Alexander Booth. I am the head program instructor and head facilitator for the course. This is the kickstart of our Capstone week. Hinton goes to you online. Karen, glad that we have you online. So it should be a fun day today. We're going to review the requirements for the capstone, how I want you to submit, what it should look like, as well as what else? As well as just the notebooks. I think there's only a few notebooks that we need to run today. So we should be able to get through the whole hour and a half here pretty quickly. Yeah, it's only one, two, three, five notebooks, and one of them doesn't work. So we should be able to get through pretty fast. But yeah, I really enjoy this capstone. I think, like I said, Karen and I have been doing this course together for almost a year. And each time we've done it, the cohort has gotten better and better with their submissions. So I don't know if that's because we've gotten better in telling people what we want to see, but it's a pretty fun activity. And I think it's very relevant, especially with the SpaceX IPO that happened earlier this week or last week. But yeah, it should be a fun time. Let's see. I don't have anything to go through the slides, as normal. So we'll just jump straight into kind of the materials. And like always, I've already run through everything in my GitHub. So you'll see that I actually have all the notebooks already run and backed up. And if there were errors, I reproduced them earlier in the week. So you'll also see that I have my capstone instructions and big ideas and example slide deck in my GitHub as well. So we'll make sure to share all this out as well in the forum post, but let's just jump straight into things. Let's get into our project scenario here for the next 2 weeks. In the data science capstone project, our goal is to take on the role as a data scientist at SpaceY, which is a completely independent and separate entity from SpaceX. And our goal is to look at SpaceX's rockets and understand the probability of a booster being able to be reused. So the booster being able to land successfully. We think that if we can predict or design our booster in such a way to optimize the probability of reusability, then we can minimize our costs versus other competitors. So that's our goal here. We have a video of the problem, and then we'll get into kind of the discussion and then the first few activities. So in week 9, we're going to be focusing on data wrangling. So we're going to be focused on data extraction, data transformation, data cleaning, and exploratory data analysis. This is then going to prep us for module 10, where we're going to work on the consumption layer, where we build out our classification machine learning problem, as well as design interactive dashboards using Dash and Folium to help relay the business insights from our study. Definitely try and look at the discussion post here. I thought it was pretty good. Basically, it was like thinking about the capstone in a higher sense, right? Like, what would you do if like, how would you approach it? What are some EDA questions that you want to ask? And think tied back to the data science approach that we talked about in week 1. So I put some thoughts in this, right? Like, does landing vary by launch site if I launch it in Florida versus Texas versus California? What if the payload is heavy, right? If it's a heavier launch, is that going to affect the probability that the booster can be reused, right? Has there been any change over time, right? Does the other things like flight number or orbit type or any combination of factors like again, like what's the common sense, right? If you're thinking, what's your gut feel? Like if I had to predict whether or not a booster is gonna land successfully, what are some common sense ideas and features that could be useful, right? So I love starting problems like this, just thinking about them logically and trying to understand what could have the most impact. From there, obviously, we're going to be pulling from the SpaceX API as well as Wikipedia. And then we can walk through about what we want to do for our machine learning model. We're going to be doing a classification model to build out this categorical probability. There's some good use cases for regression here. I had someone in a different class ask me, why not build a regression model to predict exactly the cost of the launch? And I thought that was pretty clever, but not necessarily exactly what we're trying to do here. We're trying to understand the probability of reusability and use that as a proxy for understanding potential cost optimizations. We probably need to look at more than just accuracy. I think just like with anything else, it's more likely for a rocket to succeed than to fail. And we want to be good at predicting failures, right? Just like if I want to predict if you're going to have COVID or not, most of the time you're not going to have COVID, but we have to be really right for when you do have COVID. So similar thing here, most of the time these rockets are going to launch successfully, but when they do fail, we want to be pretty good at predicting those failures. So we want to be looking at recall. All right, or log loss, but that's all week 10. So definitely good framework, get your good business understanding for the use case for the capstone before you just start diving into the notebooks. I wanted to go over the requirements for the project, both in terms of submission as well as for your own public portfolio. That's going to take us into 9.3 here. So I thought this was a pretty good step-by-step account about setting up GitHub. If you haven't set up GitHub yet in the capstone, that's no, or for the boot camp, that's no big deal. But we definitely recommend, and Karen and I require a GitHub repository for the capstone. So definitely follow the instructions here, set up a GitHub account, and you should be then able to create a repository. You may see a little bit different in terms of the screenshots. I'll actually walk through that live here as well once I finish the requirements. I think that's a good idea. I'll go through all this live just so you have it. But your goal is that every notebook in weeks 9 and week 10 is going to build. So we already said that there's 5 notebooks in week 9, and there's another 5 or 6. Oh, there's only 3 in week 10. So in total, there's going to be 8 notebooks. And you need to work through all 8 notebooks. And Karen and I would love to see all 8 notebooks in a public repository that's going to be attached to your capstone submission.
And
So,
remember that one doesn't work.
yeah,
This
but
is a
remember
good
the
step.
first, yeah, 943 is broken. But we'll get to that in a minute. So what are you actually going to be submitting? Because if you actually work your way through the media sets and the modules, you'll actually end up in module 10, where they're going to give you the slide deck. So caps or module 10 should already be unlocked. Even though I haven't officially previewed the week, it should be unlocked. Weeks 9 and 10 unlock at the same time. So let me know if you can't see it. But in 10.7, you should have the slide deck template. So this is what you're going to end up submitting, because when we get into 10.8, you're going to submit via file upload. So that's what this is saying. I need you to upload a file, right? So the upload that you'll be doing is going to be your final slide deck as a PDF. But at the end of that slide deck, I need you to include a link to your public portfolio. So a link to your repository. So Karen and I can look over all the notebooks and give you partial credit as applicable. And I'll show you what this looks like from a past cohort. But one other thing I wanted to call out, even though the capstone gives you it as a PowerPoint, I really don't care if you do this as a PowerPoint, a Google Slides, or even a Canva, whatever slide deck technology that you want. And just to show what the slide deck looks like, I've already loaded it up into Google Drive and converted it to a Google Slides, and it'll look something like this. And essentially, all you're doing is as you complete each notebook, you're going to be tasked with filling in the slides, right? So you're going to see that we'll have kind of our methodology. So this is going to be a lot of week 9. What data are you doing? How did you gather it? How did you clean it? What was the EDA that you did, right? So describe the data collection. What does the API look like, right? What does the web scraping look like? What does the data wrangling look like? All that stuff, right? What is the EDA? So we're going to be running the code, grabbing screenshots, and putting things on the slide deck. One thing that I really want to reiterate, though, is that this slide deck should not just be a collection of screenshots. I want you to do analytics, think critically, right, and put in your own interpretation of what these visualizations are showing you in terms of conclusions, right? Um, so it's not just, I don't want it just to be a bunch of screenshots, right? And you can also make this your own. The slide deck, I want to again reiterate, is a recommendation. It's a skeleton. You can adapt it, do whatever you want with it, right? All that Karen and I care about is that all the notebooks are complete and you synthesized all the information into conclusions that are actionable, right? Driving those actionable insights. So here's your dashboard. What are the important findings, et cetera, as you go. So it shouldn't be a whole lot of work as you work through the notebooks. My recommendation is to also update the slide deck as you go, just to keep it all together. But to get full credit, I'll need to see conclusions as well. Finally, in addition to the slide deck, which again you should be linking your repository to as well, I want you to also include a short, just executive summary or README in the repository. This allows other people that view this as part of your portfolio after the bootcamp to quickly understand the scope of the project, what you did, and the findings that you discovered. So it's all good to talk about this, but let me show you what Karen and I are expecting. If you check my GitHub, I actually have a couple examples of a couple past Capstone projects, including kind of their reports as well as their slide deck. Let me see if I'll actually, let me see if I can download one of these. I'll actually try and download both of them. One, and maybe I'll download all four of these just so you can see it. And I think I have the link to their repository as well. Boop, boop. Yeah, so let me look at one of these first. Let's look up James's as well. So this is what James's slide deck was. He was in one of our last cohorts earlier this year. He did it fully on his own, right? You'll notice that it's a completely different skeleton than what we see here, and that's totally fine, right? Like you can customize this as much as you want to. But as we go through it, you'll see that he has all the content that we need. He has all of his text, his explanations, right? His approach, his methodologies. And when we get down to his images, we'll see that he didn't just post the screenshots, he added in conclusions, right? So here's kind of one of the scatter plots that we made. He's got the trends, he's got the legend, and it's really easy to kind of see that, oh, over time, SpaceX has launched heavier payloads, and that is reinforced by the graphs, right? So you see that for all of them. Great labels, great annotations. I loved this. I thought he did a good job adding these annotations and things. But again, I want to reiterate that he's not just posting the screenshots, he's also including his findings and his recommendation. As eventually we'll get down to the bottom here. Oh yeah, you got the Folium charts, all that good stuff, the dashboards, really, really good work. The machine learning model, a quick comparison of the performance as well as the evaluation. I don't want to give too much away on it, but again, he did a great job posting in those visualizations as well as adding in his descriptions. He linked to his GitHub here at the bottom. So let me actually open this up. And this is going to be what we're going to walk through creating here together. So you can see in his GitHub, he did a great job organizing it. He has all of the notebooks from Module 9 already here and organized. And then he has all of the notebooks for week 10 already here and organized as well with all of the outputs. And then he has a README where he describes the purpose of the project, as well as his slide deck, which is what he uploaded into the forum to grade. And then he also uploaded his reports. So again, the report doesn't have to be anything crazy. My recommendation is you should always have like a written report to supplement your slide deck. And again, it's mostly just taking the findings and putting it into a Google Doc or a Microsoft Word. Technically, this is optional, but Karen and I'm not going to deduct points if you don't have it, but I highly, highly recommend having a written report to supplement your slide deck or almost like an executive summary, right? It doesn't have to be a full like 8 pages like James did. In fact, if you looked at the other one that I downloaded, Michelle, I think her report was a lot shorter. Yes, her report was only just a couple pages. Executive summary, and then 1, 2, 3 pages. That was it. Yeah, that's all you need, right? Just some kind of written report to help supplement your slide deck. Michelle also did a really good job with this project, and she actually kept the skeleton slide deck. So you'll see it's still the same deck, right? And she actually went through and filled everything in as well. And again, just to reiterate, what I really loved about her deck was not only did she include the links and the references, but when we get down to her visualizations, she did a great job interpreting the visualizations, and generating the insights from it, right? And what the point is, what the conclusions are, and what you can take away from it. So I want to make sure that you also understand that you have a lot of freedom with this project. You can style and design your graphs however you want to. You can design your slide deck however you want to. But for actual submission, you're going to be submitting the slide deck as a file submission. So again, this will be in 10.8. You're going to be uploading your file submission here as the slide deck, and then Karen and I will be grading the deck as well as your GitHub repository of everything that was contained within the notebooks, just to make sure that you did all 8 required notebooks for the capstone. Any questions on the requirements for the capstone project? Just to completely finalize this, you are going to be submitting a slide deck in the IBM campus materials. That slide deck must link to a GitHub repository at the end of it. That GitHub repository should contain all 8 notebooks that you ran in weeks 9 and weeks 10, as well as the slide deck itself, and optionally, but highly recommended, a short written description of the project, a short report, a short README, or preferably a bit of both, just so that people looking at this as part of your portfolio in the future can see exactly what the point was and what you accomplished. So all in all, I'm looking for 8 notebooks, 1 slide deck, and 1 short written report, and a README. So I guess like 11 things. But you're only submitting the slide deck. Cool, because you have to upload like a file. I had someone upload a Word doc with just a link to the repo, and we still were able to grade it because he had a slide deck there. But it's recommended that you just upload the slide deck and just call it a day. And I don't care if you do it in Google Sheets, Canvas, Google Slides, Canva, or PowerPoint. Cool. To create the repo, let's go over that real quick. It's not too terribly complicated. What I would recommend doing, you're going to go to your GitHub account. Then we're going to create a new repository. So yeah, there we go. IBM Data Science Stand 26 Capstone. Let's create a new repository. I'm going to call this IBM Data Science June 2026 Capstone. We can give it a description, IBM Data Science Capstone. You can also call it like SpaceX Capstone if you want. I don't really care what you call it, or just SpaceX project. The repo needs to be public, so make sure that it's toggled to public. If it's private, then Karen and I can't grade it. We're going to add a README. This should be on. And for git ignore, you can do Python. So it should look something like that. For a license, I don't really care if you give it a license or not. You can just give it the general public license if you want. And I'm gonna take a screenshot of this so I can put it in our forum. Cool. I will post that in our forum. Well, probably right now. This is what, week 9 live session? Boom, boom, boom. All right. Cool. So once we've created the repository, we're going to create the repo. And then how to upload files, right? So you got two ways of interacting with GitHub. If you follow along with the instructions, I think they just do, yeah, editing and doing things in the UI. So let's just do that. Yeah, if we get down here at the bottom, it'll walk through how to upload files. So we're good. This is how we're gonna do it, right? You're gonna run all the notebooks on IBM Cloud and then download them to your computer. I recommend organizing them on your computer however you want, however you want it organized in GitHub. Because once we are ready to submit, right, so you're going to run the code in the IBM lab environment. Once you're done with the notebook, you're going to download it, just like I've been doing in our live sessions. On your local computer, you're going to organize those downloaded files into folders for GitHub, and then we're going to upload those folders into GitHub. So here's how that's going to look. Once we have our repo done, I'm going to click on Add File, and I'm going to go to Upload Files. From here, I'm then going to go into my computer and find our class or find my notebooks that I want to upload. So let's say I want to upload module 9, like I want to upload 9.04, which are my notebooks, and 9.05. This is the folder that I want to upload. I'm just going to grab this folder and drag it into the UI. And you'll see that it's going to give me my folder name as well as the files that hopefully I've already downloaded and run. You can add in a commit message right here. Doesn't really matter though. You can also just leave this empty and it'll have a default comment. And then we're going to hit commit, which is going to process the upload for us. And you'll see there's my week 9 material or my 904 materials. Easy peasy, lemon squeezy. And then again, just include this URL at the top inside your slide deck. So just to close this out, I can't believe I closed James's repo. Let me grab his repo again. So basically, you can see how James did this, right? He created the repo just like I did. He downloaded all the notebooks on his computer. He made a folder called Module 9 with the materials in it. And then he uploaded just the whole Module 9 folder. He just dragged it into the UI. And you can see even the comment. He left the default comment, add files via upload, which is totally fine. The more hardcore way to do this is through the CLI and through terminal, but that's out of scope for this boot camp. You're going to run and you're going to create and run the notebooks in the IBM environment. You're going to download them to your local computer, organize them on your local computer, and then upload those folders into the GitHub UI to get them into the repository. Any comment on that, Karen, or anything on the submission for the capstone before I move on?
Oh, I also posted some instructions that will be useful, and I have a different organization. But one thing, the way I look at it is if you make a like a project directory with everything organized in it, then all you do is you drag that project directory one time, and you'll have the whole tree. And maybe
Yeah,
your thing
all
will
that in
say
here.
maybe you have your README file and a project directory, but that's perfectly acceptable.
Yeah, yeah.
And then,
Now there's us.
within that, yeah, with like that. And that way you once it's all organized, you just one drag and drop and you're done.
Yep. So yeah, I don't really care how you organize it. You can organize it like James did, where he just did it by the module. But technically, Karen is correct that this is a real, like, full capstone project. And for real, like, projects, we typically organize it like this, where you have your data, your notebooks, and then any
Yeah.
screenshots or supporting materials. Um, I don't
Consider
really
that
care how you
though that
organize it.
consider though that if you
I'll let you finish there,
if
Karen, unless you froze.
oh sorry. Um what was I saying? Consider that people looking at the at your portfolio, at your repositories, they're not going to know what like 9 point or whatever is or 10 point
Yeah.
whatever means. But this is what I put as this is a very common structure for a data science project that might make more sense to like somebody who doesn't know anything about the course, but is just looking at you as a project to look at, that you know how to organize a data science project well.
That's a
Just
great
my
point.
thought.
That's so Yeah, so for potential organizations, companies, people that want to hire you, then yeah, structuring it like a real data science project versus like a Capstone 9.04, 10.02 or whatever definitely makes a lot more sense. So we got a couple different ways of telling you how to organize it, but the big idea, create the GitHub repository, run all the IBM Capstone notebooks in the IBM cloud, download those notebooks and the results to your personal laptop, organize and structure those materials however you want, whether it's the data science workflow like this, or whether it's the course materials workflow like I showed you. Once you're happy with how you've got the project organized, then you just have to do a single upload to GitHub where you drag the folder into the GitHub UI. It automatically uploads all the files, and then you can commit it and send the link as part of your final slide deck. Cool. And again, just the deliverables for the capstone, you'll be submitting a slide deck as a PDF through the IBM course environment. And that slide deck should link to your repository. The repository is really what Karen and I are going to be grading. We're going to be looking for 8 completed notebooks, 1 completed slide deck, and optionally a report and README that describe the project for future people reviewing your work to make sure that you know how to do data science. So hopefully I see all of that in there. So reports, README slides, and 8 notebooks. So hopefully it should be about 11 files, plus any outputs or screenshots or supplemental materials you want to upload. Oh, team. All right. Reach out in the forums if you have any questions around GitHub or submitting or getting everything ready for that final submission. And again, remember, you have freedom here, even though we have a templated slide deck for you. Use it as inspiration. You can follow it as explicitly or closely as you want, or you can expand on it or change it around or organize it however you want, right? Do this project like all I care about is that you do the notebooks and then you synthesize the information from the notebooks appropriately in a way that can drive downstream decision making and analytical insights. All right, so for the next 45 minutes or so, I wanted to tackle some of the notebooks. So let's get into that. We'll go back into our week 9 media sets. And again, feel free to drop a comment, Hinson, in the chat or anything if you have any questions on this. I think I also saw that you couldn't access some of the materials. Oh, that's a good point. I think the week 8 materials, they may have been locked if you didn't fill out this confirm certificate information. I saw this as well. Like if you didn't confirm this, then didn't submit it, then this locks me module 8 for you. So make sure to confirm your certificate information so that you get everything sent at the end of the boot camp. All right, but let's get back into the media sets. All right, so as we said, our foundation here is that we're doing this data science project on understanding the reusability of SpaceX boosters and understanding the probability of that. So in week 9, we're focused on data collection, data wrangling, and exploratory data analysis. So they walk through exactly what you're going to be pulling. We're going to be doing some API scraping from the SpaceX API, or we'll try to at least. We're going to do some web scraping from various Wikipedia pages that have historical launches from SpaceX. And then we're going to synthesize everything together into a like single source of truth. I think we put them into a database. I think we do some queries. And then we're going to do our exploratory data analysis to make sure that we have our own domain expertise of the underlying data sets. All right, let's get started with the first notebook here. I think we have a few notebooks in 9.4. Yeah, so we're going to start with the first one here, which is going to be, how do I go back? I guess head back. This is going to be our API scraper. So if you've been keeping up in the forums, you'll notice that unfortunately, the API wrapper that we use to access SpaceX, or SpaceX's API, has been publicly archived. And unfortunately, as of like literally last week, great timing. We needed one. Come on, guys. So unfortunately, the API that we're going to be hitting for SpaceX is currently down. For example, if I try and hit this URL just to get their latest launches, it throws an error. So yeah, the web server is down. I had a single tear fall down my face when I learned about this. So I was very sad. Luckily, though, this API is only a source for the first of our 5 notebooks in week 9. We end up having a cached version of the JSON response that we'll use in the synthesis notebook, where we combine the web scraping with the API notebooks. And as I mentioned, uh, that's all we need because then we pull from the database, do our EDA, and call it a project. So let's walk through what this will actually look like when you run it. You're not going to get points off for this notebook if not running, but you should still include the notebook in your submission and highlight the fact that the API is down or broken in your slide deck or in your executive reports. So just so again, over communicate so people looking at your code doesn't think that, oh, this was just a broken notebook, right? So let's go ahead, clear outputs, and start running in our virtual environment here. So we'll set up our libraries, and then we will make sure that we've loaded everything in. While that's launching, you'll see that we have all of these helper functions that help us pull in metadata from the SpaceX API. So we'll see here that in this function, it's going to input a rocket, and we're going to use that rocket to then pull metadata about the rocket. Obviously, this API, though, is broken, so this function is not going to work. But we'll show that here. I feel like all my tabs in this has been. So I'm being a little bit OCD, fixing my tabs. But I won't do that for that one, so we'll just do that here. All right, so as I run this note, this will still work because we're defining the function, we're not executing the function. We'll do that for other helper functions here, essentially where we take information and then pull metadata from the API, specifically around the launch pad and payload, and cores as well. You'll also see that we're going to be storing the results in objects. This takes us back to what, week 4, week 5, where we talked about object-oriented programming. But anyway, let's just prove that the API doesn't work. We can define the URL, and then we can make the request. And then if I check the status code, it shows a 521, a little bit different than a 52. I think the difference here is that, yeah,
It
is
just means
down.
it's offline, just down offline.
What was 522? Oh,
That was a
timeout.
timeout on the Cloudflare part. So in other words, Cloudflare couldn't fetch it.
So now we have the web server is down. So the API is not serving information back to us. So womp womp. And if we check the content and the JSON, we'll see that it just says the web server is down and there's no JSON data to extract. But that's no big deal. If you wanted to, we can now finish. You'll actually see that in this first cell, we actually have our cached version of the API call that we did a few weeks ago. And we can see that this, well, if I made the request to that, I guess I didn't copy that code down. Requests.get. We'll do that here too. Request.get the static URL. The static URL works. That returns the 200, and we can actually pull the data from it, which should work as well. So this is actually what the static response looks like. We do have this information of all of the launches going back to 2006. The problem with the rest of this notebook, though, is that we're supposed to be using this payload to then get metadata from those helper functions, right? Let me actually show you what the data looks like now. So we have this beautiful data frame that works. But all I have are IDs. I have this rocket ID, this payload ID, this launch pad ID. I don't actually know the type of rocket, the type of payload, or anything. So that's what our helper functions at the top were trying to do, right? Given the rocket ID, let's go get the rocket information, specifically the rocket name. Given the launchpad ID, let's grab the latitude and longitude and name. So we can get this far into the notebook, but anything else from here is going to fail. So you're going to see we're going to have our lists, our objects, but now when I call my helper functions don't work because obviously, even though I have the ID, I cannot make a valid request to the API. So if we run through the rest of the notebook, we'll get errors everywhere else. And when we look at our final data frame, it's also going to throw an error because it is broken. So up to you. You can finish running this notebook with all these errors, or you can stop at the end of, I guess, where we were able to generate from the static URL. So up to you if you want to finish running this through. I am going to finish running it through just for completeness here. And then for the export, I'm actually going to I'm going to save this off and say like error, like this one, like broken. So, oh yeah, I couldn't even save the CSV if I wanted to because it doesn't work. All right, so I'm gonna save this off, and then, like I mentioned, you're gonna download the notebook. So we're gonna right-click on the notebook and download it. And then for completeness, here's the what you're actually supposed to generate. I'll put that in my GitHub so you have it. So again, remember, once you've done all the notebooks, this is where you go into your local file explorer or finder, organize those notebooks however you want to in folders, and then drag those up into GitHub. All right, so even though this first notebook is broken due to the API being taken down, the other four notebooks in week 9 should work fine, or they did when I tested them all earlier in the week. And note that in the future, we've already reported this up the chain, and we're working on getting a new API used for this for future certificates. Some of the other good ones that are like the Rocket guys like API. What's their API called? I thought it was like LL. What was it called? The Launch API? I forget what it is. Rocket. Oh, there, the Space Devs, LL2. I really like this API, which is like a real one and also includes SpaceX, but I did not have time to like refactor this notebook in like a day to use this API. But know that in the future, we're working on solutions here. But for this capstone project, for this cohort, it's totally fine if you have one broken notebook. All right, so let's keep going. I got about 30 minutes here. I want to tackle the other actual working notebooks. All right, so let's move into the web scraping data collection. This is going to be the other one in 9.4. Oh, and then we got the data wrangling one. All right, so let's do our other web scraping notebook here. So same idea. I'm actually going to show you the website that we're going to be scraping from. Boop, boop, boop. We're going to be scraping from this list of, oh, we've even got some cool little visualizations and stuff. They should have some tables here. Here we go. We got a table of all the launches that they've done and whether it was successful. And here we actually get like the metadata. We got the metadata about the payload, the metadata about the launch sites, etc. So we have all that other information that we wanted to get from the API here on the Wikipedia page. And it's a very long, they've done a lot of launches, obviously. So we got a lot of information here. So let's work through knowing everything we know about Beautiful Soup, and let's try and scrape this website. So again, we'll make sure that all of our libraries are installed and ready to go. And then we've got some helper functions that were already given to you. Mostly it's things about grabbing a date time as a real date time scraping out things around the booster version, the landing status, the mass, etc. So just making sure we fix all of our encodings. Make sure to run this because if these functions are not defined, our scraper is going to break. To make sure that everything is consistent, we're going to be pulling from a snapshot of this Wikipedia page, just so we all have the same data. And now we can get to work. I've already filled out a lot of these cells from when I tested this, but you can reference this as much as you want. One thing that I want to call out though is when we just request Wikipedia, we act failure. And this is something that Karen mentioned in the forums, if you've been keeping up with the forums for week 9. When you web scrape Wikipedia, it asks you to respect their row policy, which basically saying, hey, we don't just allow unauthorized random robots to be scraping our sites, right? Specifically, if you are a robot, you need to declare yourself. You need to declare who you are, right? Who are you and what are you doing, right? So there's some really interesting stuff about this. But for us, all that matters is that we have to have a header in our request. So here, this is something that Karen and I threw together. It's declaring us a as an educational only robot. So once we've given that header, we should be able to make the request to the URL. And this succeeds. Knock on wood. I think it's just pulling the cached page. There we go. So that succeed, and we got the response brought back here. So now we move into the beautiful soup part of this. Let's soupify the HTML, and we can extract the title just to make sure that we extracted the right page. And this is the right one. List of Falcon 9 and heavy launches on Wikipedia. Successfully scrape the website. So now let's actually pull the data out. What we're going to do is we're going to find all HTML tables, and we actually have 25 of them. Let's grab the right table. I think I may have a typo here. Um, Maybe this is the right one. I think this is the right one. So we're going to grab the third table, so index 0, 1, 2. And then from there, we should be able to, hopefully this is the right table. Let me just double check because I ran this locally the other day and I was like, I think it was the wrong table index. But let me just double check. Oh, it is the right table. Okay, cool. So we should be good here. Let's keep moving. Let's go ahead and what we're going to do is for each table header, right, we're going to extract the column name using one of our helper functions. And if all goes well, we should have this right here. Flight number, date and time, launch site payload, payload mass, orbit, customer, launch outcome. And if you're curious, we can actually go find that in our Wikipedia page. I should be able to go look for this flight number. I don't think it's this table. I think maybe it's one of these, right? Flight number, date and time, or maybe I should have used their launch site payload. I think that is right. Payload, mass, orbit, customer, launch outcome, booster landing. All right, so this is the right one. So we are able to pull this table. I was going to say I should have pulled the snapshot one, but it should be fine. All right, from here, it should be pretty easy. We're going to just declare our data frame, and then we're going to loop through the table, right? And this was kind of annoying to write out, but essentially what we're going to do for each row, once we've found the table, for each row in our table, we're going to grab the table cell, and then we're going to use our helper functions to fill this out. So it's really, I think most of this is given to you. I think it's just the to-dos. So you'll see that it's pretty simple. We need to grab the date and shove it in our list, grab the time, shove it in our list, right? And I think I printed date time list when I did this originally. Just so, yeah, there you go. Just so that you knew what we were actually pulling out. But this should work. Shove everything into your lists. Again, very convoluted way of doing it, but it works. And when all goes well, you should hopefully end up with a full data frame that's representative of the underlying table, right? So I also have an easier way of doing this if you want, which is my pandas read only. Let me see. I think I grabbed, what was that first launch table? I'm trying to grab this variable name. Oh yeah, there we go. So we found this is the name, this is the variable name of the HTML table that I want to turn into a data frame. So pandas can just do that. You don't have to do all this nonsense. We'll see how this looks. Let's do test df equals. So all I'm doing is I'm stringifying the HTML table and then I'm turning it into a pandas data frame. Oh, it doesn't work. Oh, I need the io.string, right? I forgot how to do it.
Oh, do I remember?
I don't think so.
Wait, have it.
I'll just go to Gemini T real quick. That's what I want. All right, let's pop
I
this
think I
back in
did it.
here. Good job, ChatGPT. I knew this was an easy one. Oh my God, what a big error message. We did this in our web scraping week, so just go back and check those. I think that was week 4, week 3, week 4, something like that. So anyway, we're parsing out the string of the HTML table, and it should look something like this. So then from here, we can just drop the columns that we didn't need. So yeah, like we could have fixed out our date time a little bit better. I guess they did some other data cleaning stuff because yeah, some of this definitely is pretty messy. So note that this is quite messy though. So one thing to note, right? Obviously, we could have definitely we could then do the pandas way and then clean it up. But that's why this function is so crazy because they're doing all the data cleaning and the same extraction of the web scrape. Uh, Once we're done, we should be able to shove it into a CSV and call it a day. So I'm going to save the notebook. And so now I'm going to download for our GitHub backup or for a submission. I'm going to download the web scraping notebook as well as the resulting CSV. And again, you're going to organize that on your own time. All right. Those are the most complicated notebooks. The rest of these should fly. They're pretty quick. But yeah, the data extraction is always the hardest part. All right. Again, feel free to highlight us with questions in the Zoom chat as we go. Let's skip over to the next media set. So we're gonna jump into 9.5 here. Where was the wrangling one? Did I miss a notebook? 9.4.8. Oh, I guess I did miss a notebook. Yeah, so we're gonna skip over the quizzes and then we're gonna finish up 9.4. It's gonna have some videos about data wrangling. Again, this is where technically we're gonna be combining the API data set with the web scraping data set to create one full single source of truth. So we have our video on this, and then we have our last notebook here to go through on the data cleaning side or the data wrangling side. So, so we're gonna wait for our kernel to connect, and then we'll go ahead and clear output of our cells and get ready to go here. So same dealio, we're going to import our libraries. And again, this is why I mentioned earlier, the API is not a requirement because we actually reference a cached version. So this dataset part 1 is the API results, right? So we can grab that. And then if we continue down here, I'm sure we pull in the web scraping one. Or I guess we pull in the web scraping one maybe in the next notebook. But here's our beautiful data set that we should have made from the API. And we can do some basic analysis. We want to look at our, oh my God. Sorry. Spain apparently tied. Who are they playing? Like Cape Verde? That's crazy. Spain was up. That's crazy. I thought Spain would demolish Cabo Verde. I thought Spain would demolish them. Crazy. Anyway, I'm watching a lot of World Cup recently. Anyway, let's get finished up our notebooks because I only got 30 minutes. We're gonna look at the null values. So again, we can just look at this. This is what they want us to write. Look at the is null sum. I think this is really difficult to read. The only one that is null is landing pad. I like looking at the dot info and the D types. So again, if we look at our dot info here, we do see that we have about 26 null landing pads. What is this? DF shape 0 times 100? Oh,
I would,
28 per. Oh, this is a percentage.
yeah,
28% of the landing pad is null, but 26 raw counts are null. And so if I do
well,
my math, let me do my math. 26 divided by 90 is that 28%. Okay, so our numbers do match up.
but the
All right.
simplest way is just do the is null dot sum without
Yeah,
the
without
aggregating of it.
making it a percentage. Yeah, I
And
agree. Let me do
it will
that.
just give you a nice list of, you'll just see how
We
many
have
missed ones there are.
26.
Yeah.
Yeah, great job, Karen. I appreciate that. All right, let's keep moving on here. We're going to do a little bit of exploratory analysis. So if we look at our value counts, we'll see that we had 55 at this launch site and 13 at another. So definitely some bias and skew in which launch site SpaceX prefers to launch, which seems to be Cape Canaveral or Kennedy. No, Cape Canaveral is their popular one. Yeah, or no, yeah. Cool. We can also look at where they're launching into orbit. So again, the point of this is supposed to increase our domain expertise of the underlying data sets. So you will see GTO is geostationary transfer orbit, and that is the most popular orbit. And then we can look at the landing outcomes, and we can see that some of them were in the ocean, and some of them landed on a drone ship. So we probably only want to look at kind of the bad outcomes. So as we said, the bad outcomes we can define as failing to land on one of these objects. So now we're going to do our feature engineering or our target engineering. We want to build out our landing class. Notice that I just have this list comprehension here, but you can also do this as a regular for loop if you want. And now we can add in our prediction target. So our target's going to be this DF class. And we can see that the first 5 launches, the first 6 launches all failed. And if I look at them, we can see that the results for all of these, where was the result? Oh, the outcome. Yeah, the outcome was none, 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 and then like false ocean. So we can also now look to see if there's any bias. And if I actually do df.class.value counts, we'll see that there will be a little bit of skew. So as I mentioned at the beginning, 60 of the 90 launches were successful, right? So we're going to be a bit biased here. Um, we really care about the failures, and only about 1/3 of my launch attempts ended in a failure. So we're going to have a little bit of an imbalanced classifier. And also, if you look at this a little bit closer, we only have 90 rows. And if you remember anything from my lectures, especially when we talk about predictive analytics, you need a lot of a high sample size, especially if we start using exotic algorithms such as XGBoost, random forest. And we really don't have that big of a sample size here, only down having 90 rows. So something to look out for. Maybe we could do some smote, we could do some synthetic engineering, but that's definitely going to be out of scope for this analysis, but definitely worth highlighting as a limitation of your data science work, right? A limitation of this data is that we only have 90 observations, which is not enough to accurately have confidence in a full classification model. All right, once we're done with that, same idea, download everything to your local machine so you can organize it before uploading to GitHub. All right, 2 more quick notebooks, and then we'll tackle through the actual week 9 quiz, which is your last quiz. There's no quiz in week 10. So you got 1 more quiz to get through, and then just the capstone work. Let's skip over to the next activity here, which is the EDA. As I mentioned, the EDA notebooks are also pretty quick. We got some good videos here to talk about how we're going to engineer our features. And let's do our first one, which is going to be the SQL notebook. And then we're going to do one with Seaborn and then wrap. Again, I want to reiterate to take your time with the project and really work on make sure that you understand the data, that you understand the project and the problem, as well as the limitations, right? We're just because some of these notebooks can be short and you don't need 60 minutes, doesn't mean you should be running through them in 10 minutes like I am. Definitely take your time, add in more code, add in more cells. You have freedom here to really make this your own. So start thinking critically, be curious, ask your own questions of the data as well. All right, for the sake of time, though, we're going to keep flying through this. Let's go and make sure that we have our database already installed, and let's practice writing some SQL queries. How's the chat? 5 comments. We all good? Oh,
Oh,
yeah, no
actually,
worries if you're a little bit behind, Tinson. Oh, you got it,
yeah,
Karen.
she was
Thanks
a
for
little
covering
concerned
the chat.
about whether your GitHub stuff would disappear at the end of the course, but I don't think so. You think you keep them around?
Yeah, I keep my GitHub around and also I back up all of our videos on YouTube. So if you go find my YouTube, I have all of our lectures and recap videos and stuff here. So you'll have all of the live content backed up as well as my GitHub backed up. And I think you have access to the IBM course for a few more months too. So I don't think you'll be kicked out anytime
Yeah,
soon. I
they
think,
do they do keep it around for a little while that you can
yeah.
review material that you paid for, after all.
Yeah, the other one is going to be just getting the grades in. Karen and I have to find, that's a good thing to call out now. Pull up a calendar. Uh, Technically, what day is it? Today's the 15th. Our week 10 live session's the 22nd. And then technically, you're supposed to be wrapping up the capstone on the 24th. I think Karen and I can give you that weekend, but starting the week the 29th, 30th, we're going to be grading. Usually, I have like a week to get the grades finalized. So if the capstone ends on the 24th, we have to have our grades submitted by the 1st of July. So you can start submitting anytime next week. The earlier, the better. Note that if you submit after the 24th, you may have to like check a box saying ask for an extension. All those extensions will be granted, and I'll also be managing this if you have any issues. So feel free to take the weekend of the 27th, 28th, but you should be submitting everything by the end of that weekend at the latest. That gives Karen and I 48, 72 hours to get the grades turned around. Once we get the grades in, sometime around the first, then I think they're held for a week while IBM checks everything, and everything should be released sometime around the 8th. So sometime the week of the 6th, the 13th, everything should be fully closed out. But you should be done with your work as a student by the end of June. We'll have everything graded by the beginning of July, and then everything should be released in the week or two following that. So yeah, even if you're a little bit behind the modules now, just try and get everything submitted in the next, what, 7, oh yeah, almost 2 weeks. So you got about 12 to 13 days to get everything kind of wrapped up here. All right, just to finish off these last two notebooks, we're going to connect to our database. And like I mentioned, our goal is to take that CSV we made in the last one, which again, we backed up for you already. So there's no dependencies. We're going to write that CSV to our database. And then we're going to make sure that everything's verified and ready to go. So if we write a quick query, select star from our table, limit 5, we should kind of get these results back. And so now we can start interacting with this data set using SQL, which is pretty cool. So we'll just run through a few of these queries here. Task 2, select 5 records where the launch site begins with KSC. Notice that I'm using my wildcard, but doing it at the end of the string. So we're matching where launch site begins with KSC. And here are 5 launches for that, ordered by their launch dates. I want to sum the total payload that is launched by the customer NASA. So NASA is my customer here. And we've launched 45,000 kilograms of payload for the NASA customer. Same idea. We want average payload where booster version is equal to F9V11. So again, pretty straightforward here as well. We want to list the dates where the successful landing outcome in a drone ship was achieved. You don't need to use a min function. That's kind of a weird question. Here's how I did it. You can probably do it differently if you want to. I filtered where landing outcome begins with success and contains the word drone ship. And then this is going to bring back all of those rows. And so the first one is going to be April 8th. So I think that's where they wanted the min, right? They just wanted the min date. But I think the answer is going to be April 8th. I can add in a like limit 1 here too. So there you go. April 8th is the last one. Next one, list the name of the boosters which have success on a ground pad with payloads between 4,000 and 6,000. So again, we're just updating our where clause, bring stuff back to look at, order by date, and we had 3 rows that match this condition where they were successful on a ground pad with a payload between 4 and 6,000. Now we can do our first group by. We're going to do an aggregation on mission outcome, and we can see that most of our missions were successful, even if the booster rocket was unable to be reused. I think I did a different one because if I look at the results here, yeah, you'll see that we have 3 successes, right? So technically we should have 100 successes and 1 failure. So I went crazy and I added like a crazy case statement. So when the mission outcome contains success, then I bucket it as success, else failure. And then I just have to group by that case statement as well. So when we do this, this gets us our 100 successes. Again, this is excessive. You don't have to do it, but just an example of using more exotic and more complex SQL querying syntax. Okay, we only got 3 more. Uh, List all the booster versions that have carried the maximum payload with a subquery. Here's my subquery. I'm using it in my where clause. Select the max payload, and then I'm filtering where the payload is equal to that max. This is a good use case for a subquery. And we can see these are all the booster versions that have carried the maximum payload. This one was pretty annoying. SQLite, which is our database, doesn't support date times. So we had to like hack it using substrings. It's all a mess. But basically, let's start with the where clause. We want where my landing outcome is a successful ground pad. I want where the year is 2017, which is going to be the first 4 characters of the date string. And then if I take the next 3 characters after that, that'll be the month name because it'll be just the 01 or something. So when we run this, we end up extracting the year as the first 4 characters, and then the month as the next 2 characters, as well as the landing outcome and boosters and stuff. If we wanted to, we could go a little bit crazy then, and I added a case statement where based on the extracted substring, I then convert that to the month name. So this actually is a little bit cleaner as a result. So in February 2017, we had a successful landing of this booster at this launch site. Last one, we want to count the number of outcomes between these dates. Technically, even though there's no date time, it's going to be filtering these as a string, which still works in this case. And we can see that these are the results brought back where we grouped by the landing outcome between these dates. So no attempt was our most popular one, and then success on a drone ship. Cool. We can then close the database connection. Sweet. I'm going to download these again for completeness. Again, this is where you organize them locally on your personal laptop before submitting it on GitHub. And we got one more notebook and the week 9 quiz, and then we'll be out of here. So let's move to the EDA. So far, what have we done? We've web scraped from an API. We've web scraped from a web scraper. We have wrangled and increased our domain expertise of the knowledge, done a little bit of data cleaning and some data wrangling. Then we wrote some exploratory queries in SQL, and now we're going to create some exploratory data analysis of visualizations using matplotlib, pandas, and Seaborn. And that should then set us up nicely for week 10, where we're going to create our interactive Folium and Plotly visualizations and dashboard, as well as put into a machine learning model. So even though week 10 is only 3 notebooks, each one does take a long time, like almost an hour. All right, let's knock out this last notebook and get us out of here. All right, so let's import our required libraries. And remember, our goal for this one is to make some visualizations using Seaborn, Matplotlib, and Pandas. So wait for everything to finish installing, which looks like it almost has. And now let's read in our data set. And then from there, we're going to create some visualizations. So first, we're going to do a Seaborn cat plot to look at payload mass versus flight number. And again, this is going to be, if you remember from the slide decks I showed you from the examples, this is one of the visualizations you'll need on your slide deck. So there's one example. Then we can do a scatter plot. I guess this one did the cat plot. I'm doing a scatter plot here. Maybe that's the same one. I'm doing a scatter plot here. Oh yeah, it even says in the that's weird. The instruction says cat plot. This one says scatter plot. Whatever, it doesn't really matter. We can see we're scattering our flight number by launch site with a hue based on whether or not it was successful. And again, I want you to look at these graphs and make some conclusions. We're then going to look at the relationship between payload and launch site, see if there's anything different here. We can definitely see that the heavier payloads do seem to go out of Cape Canaveral, maybe. VAFB is definitely lower. We're going to look at the success rate of each orbit. So first we have to do an aggregation. We're going to group by orbit and then look at the average success of those orbits. And then we're going to plot it as a bar chart. So we can see that for GTO, we only have about a 50% success rate. So it would be good to also maybe annotate this or maybe include sample size. Maybe a bubble plot would be a better graph for this instead of a bar plot. It looks like I left one as an exercise for the reader. Plot a scatter plot with the x-axis flight number and y-axis to be orbit and hue to the class. I'll do it for you just because I like y'all. So let's go ahead and do the scatter plot for task number 4. My x-axis is going to be flight number. Oh, this is flight number is one word. Flight number, my y is going to be orbit, my hue is going to be class. X label is flight number, Y is orbit, and this will be flight number, orbit. And you have full creative power to change the colors, to change the labels and titles as you go. So it does seem like as our flight went on, we started doing more other orbits, right? So we didn't do some of these other orbits until later on in our SpaceX career.
I think I did cat plots because I'm looking at mine. And the nice thing about cat plot rather than scatter is it tends to put a little jitter on those instead of a straight line.
Yeah, I like that too. We'll keep that as cap plot. Yeah, and again, like I don't really care. Karen doesn't care how
Yeah,
strict that's on
it's just
this.
that, I find categorical things with scatter plots kind of unimpressive because they tend to just put everything in a straight line.
Agreed. So I like this. I'll keep this one as a cap plot just for the example. And you can definitely see it jittered here on the lines. I guess for comparison, maybe we'll do a scatter plot one and a cap plot one. Yeah, 'cause for the scatter plot, you see that we have all these overlapping lines, but for the cap plot, they jitter it a little bit.
We see them separately.
Yeah. Cool. So just to keep going here, we're gonna do payload versus orbit, and we can do see that some orbits require certain payload masses. Like our GTO seems to be between 3 and 8,000. And of course, we can do a cap plot here if we want them to be jittered. Yeah, I kind of like that. All right, cool. Let's keep going. Visualize launch success by year. So we're going to extract the year using our string manipulation. So let's do that. So we should have a new column now called year, hopefully. Oh, df.date. Our date is now just the year. We can now group by dates and then look at that success rate as a line chart. Change over time is a great use case for a line chart. I would just maybe change the grid, make it a little bit less in your face, all that stuff. But again, I'll give you that, you have that full design um, leniency as the student to design these graphs however you want. All right, now we're going to prep for machine learning. Let's do our feature engineering and one hot encoding. That gives us a graph like this where we can see we've broken out our orbit, launch site, and serial into binary sparse vectors, which then we can put into our algorithms. We're going to make sure that everything is afloat. And now we should be ready to go. We're going to take this data set. Notice that we have all numeric data. Everything's afloat. We're not missing anything. There's no null values. And we should be able to use this data set for our machine learning, where we're going to predict the class. So it looks pretty good to me. And let's save this off. So again, the point of this notebook is to do that exploratory data visualization and then clean and prepare the data for machine learning using one-hot encoding and imputation. As always, I'm downloading these notebooks to be used, as well as the outputs to be used in my GitHub submission. And you should be taking snapshots or even saving like these images off as you do them to put into your slide deck at the end. All right, I think that's all the notebooks. So let's go ahead and wrap up with the week 9 quiz, and then we'll review our big ideas and get out of here. I think the quiz is pretty quick. Yeah, only 8 questions. Which of the following will retrieve 20 records from this table? Select star from table limit 20. That's the vocab for SQL that we're looking for. Which of the following displays the minimum payload mass? Select a minimum payload mass. I guess technically D does as well, but this is way too convoluted. I'm expecting it's C. You're writing a query that'll give you the total payload carried by booster. Should be stored in the mass column. You want the result column to be called total payload mass. Select sum as total payload mass from table. It's not B because we're not renaming it. It's not C because they're using count, so it should be A. Which query is used to display the mission outcome for each launch site? We need a group by launch site, and we're looking at mission outcome counts launch site from SpaceX table. I think we want count here instead of sum, so it's going to be B. What are the unique launch sites? Oh God, I already forgot. I'm looking at Karen if you can help me, but let me see. I'll have to go double check. Let me go find one. Look at here's one I did earlier. Where are my launch sites? They didn't give me launch sites here. I thought we made a graph with, oh, there we are. These are my launch sites. All right, SLC 4E and then 39A. So 39A, there's only three launch sites. Why are they doing four? What's the unique launch sites? Maybe none of the above?
39A. 39A. It's second one. C rather. I'm sorry, C. I think that's
39A is SLC 80 there. I only have SLC 40.
44E and 39A.
No, I
40,
have SLC
39A.
40.
Yeah, look, go back at the
Oh,
40,
B.
39A, 4E. That's, oh,
What
they
about
know.
this one? What
They have
about
another
LC
one.
40
They
though?
have another one. I would
Hmm.
say C because I know the first three are right.
Well, this one, mine says SLC 40.
Oh, what does it say? What did it say
Let
on
me look at
there?
the data. Let me look at the data wrangling notebooks. There's some weird typos on this one. I thought we did. Oh yeah, launch sites. Here we go. So it's, I guess it's none of the above because I only have three launch sites.
Oh, trick
I'm
question.
going none of the above. We'll see if I get it right. There's four listed in each of these. So I'm gonna go none of the above. We'll see how we do. What type of data is best represented by a bar chart? Categorical data. What is the total number of columns in the features data frames after applying one hot encoding to everything? That's a great question as well. If I check the notebook, we should end up with 80 columns by the looks of it. Yeah, 80 columns. So let's go with 80. Cat plot code shows the scatter plot and hue to class. The cat plot code shows the scatter plot of flight numbers versus launch site with X as flight number, Y as launch site, and hue as class. I think this is right. This looks fine to me. Y, X. I think that's fine. Yeah? All right. Let's see how we did. Oh man, we missed one. Which one did we miss? Let's see. I'm so mad at this question.
It's that one.
Maybe
I'm pretty sure I would do C.
I
They
think
said
it's
C.
maybe the sequel. I think maybe it's coming from the sequel notebook. So let me
Maybe.
check the sequel notebook. Oh, there we go. Yeah, the sequel notebook gives you a different answer than the
Oh,
Python notebook. All right, so from the sequel notebook, it's gonna be the two LC40s, 39A and 4E. So it'll be LC40, SLC40, 4E, and 39A. So it's gonna be B is the answer to this one. So that's just the trick for question five. Make sure to reference the sequel notebook, not the data wrangling notebook like I did. And yes, they should be consistent, but it is what it is. Yeah. All right. Let's wrap things up with our big ideas. Again, I got my big ideas here just to make sure that I covered everything in the lecture. Big point of this, right? This is a real world capstone activity with real data. This is real launch data from SpaceX, right? Real data doesn't start clean. You have to go out and get it yourself. APIs, websites, FTPs. You have to gather everything and convert everything to a consistent tabular format. You got to keep your mindset of building out data pipelines. Most of the work in data science isn't machine learning and modeling. It's getting and wrangling data to be used for predictive analytics and business intelligence. We already know about APIs. Data wrangling is where projects are won or lost. If you have bad data, garbage in, garbage out. If you do poor data wrangling, then you're going to have poor dashboards and poor models at the end. Make sure you understand your data, think logically, have critical thinking about the features and patterns that exist. Do they match your gut feel, your gut checks for what you should actually be generating here? Definitely look at correlation versus causation and combining variables. If you do your EDA well, then no longer are you guessing or assuming your model is right. Bring your own human intuition to the predictions. SQL is great for doing your aggregation and filtering. You're going to use both SQL and Python in the real world. Data science is a business problem, right? We don't just write code because I tell you to. Why are we trying to solve a business problem with data here? Why are we trying and how are we trying to get actionable insights and drive decision making from our work? Reviewing of feature engineering, one-hot encoding, null values, creating your target variable, label encoding, all that good stuff. Better features typically leads to better models, not necessarily fancier algorithms. Start using GitHub for stuff. Version control gives you history, it gives you reproducibility. It lets this be a real scientific experiment that someone else can reproduce and share and be part of your wider portfolio. And again, start thinking of data science as a full end-to-end pipeline, going from data collection, wrangling, EDA, all the way to modeling and dashboard design concepts. This is where you should be realizing that you're actually doing real data science now. And like I said, week 10, you're going to be doing your dashboards, visualizations, and machine learning. So it should be a fun week that week as well. All right, just to finish up, close us off here. The capstone is due sometime next week between the 24th and the 28th. Earlier is always better, so Karen and I can get those grades in. We'll get the grades in by the 1st or the 3rd, and then you'll have them sent back to you probably a week or two after that, sometime around the 8th or the 15th. Now, what are you submitting? In the IBM forums, in the IBM classroom, you're going to be uploading and submitting a file. You're going to be uploading your slide deck as a PDF. Please include a link to your GitHub repository as part of that slide deck. In that repository, we're expecting to see all 8 notebooks, as well as any other supplementary files and resources that you created during the capstone. We also expect to see your slide deck as a PDF, as well as a short report and README, just explaining the project and summarizing your key findings and conclusions. All told, we hope to see at least 8 files, 8 Python notebooks, 1 slide deck, 1 short report, and 1 README in the repository. I recommend doing all that locally and then dragging and dropping and uploading everything into GitHub. One thing on the README, while I got you here, actually, quick thing on the README, you don't have to create the README in your on your local computer. If you initiate the repo with a README, you can actually just edit the file in place. So, hello, this is an edit in place. And then you can submit it and commit it like that. So you can basically just copy whatever you put in your report, paste it into the README in the UI, and call it a day. So hopefully that helped. All right, I got 1:30, 2:30 Eastern. So I will see you all for our last sad live session next Monday at the same time. I will still post our recap preview video on Friday, and I'll actually do a last recap video for week 10, end of next week, that again doubles down and reiterates all the expectations for the capstone deliverables. If you have any questions about the gradebook, reach out to Karen and I ASAP. We have full control over the grades until the end of the boot camp, which is coming up here in the next couple of weeks. So let's get everything locked and loaded, squared away, and make sure that you all graduate and earn your certificate. Thanks for following along, and please continue to reach out in the chat in the forums if you have any questions or thoughts. See you all next week. Have a good week, and I will see you online and see you for our last lecture next week. Thanks, everybody. Take care. I'm going to pause the recording.